So question 2, we have two equal positive point charge Q1 equal to Q2, 2 microcoulomb, locate at x equal to 0, y equal to 0.3 meter, and x equal to 0, y equal to negative 0.3 respectively. So we visualize the locations of the charge. So one of the charge is at 0, 0.3 meter. So we have a positive charge here. I label it as Q1, 2 microcoulomb, and then another charge is at 0, y, negative 0.3. So negative 0.3 meter. So below the x-axis, we have the second charge, positive also. The magnitude of charge is the same. I denote by Q2, 2 microcoulomb. Okay, so what are the magnitude and direction of the total electric force that these charges exert on a third point charge Q equal to 4 microcoulomb at x equal to 0.4 meter, y equal to 0. So we have another third point charge at a locations 0.4. Okay, so 0.4 meter, y equal to 0, we have another third point charge, positive 4 microcoulomb. So I label this as Q3. So the third point charge. So what the question wants, we need to determine the magnitude and direction of the total electric force that these charges exert on third point charge. So we want to find the total electric force exert on the third point charge, 4 microcoulomb. Okay, so class, we know that in between charges, there will be whether attraction force or repulsive force. So let's say this is the straight line that joining the charge Q1 and Q3. So Q1 will exert a force on Q3. So Q1 akan kenakan daya ke atas Q3. So daya apa? So Q1 ni positif, Q3 adalah positif juga. So Q3 akan rasa daya tolakkan daripada Q1. So Q1 akan menolak Q3. Okay, there will be repulsive force between the charge. So Q3 akan rasa daya tolakkan ke bawah sepanjang straight line yang menyambungkan dua charge ni. So we have F31. Okay, pada masa yang sama, kita jangan lupa Q3 akan rasa juga force daripada Q2. So this is the line that joining the two charges. So this is the straight line joining the two charges. So Q2 adalah positif, Q3 pun positif. So Q2 will repel Q3. So Q3 akan mengalami force ke atas ni lah, ditolak oleh Q2. So this is F32. Okay, so the two forces that acting on Q3 is at a certain angle. So kita boleh cari angle ni. So angle theta ni akan sama dengan sebelah sini lah. So angle theta ni boleh kira daripada tiga tempat ni. So according to the right triangle, here is 0.3, here is 0.4. So we can find the theta lah. So the tangent theta is 0.3 divided by 0.4. So when I shift tangent, I'll get the angle is around 36.9 degree. Okay. So sama juga untuk sebelah sini sebab distance dia sama, 0.3, sini pun 0.3. So samalah angle dia theta juga. Okay. So after we have drawn the vectors of forces, electric force that act on the charge Q3, then we will calculate the magnitude lah. Kita akan kira dulu nilai F31 dan F32 using the Coulomb's equation lah, Coulomb's law. So F31 will be K Q1 Q3 over R squared. The R will be the separation lah antara charge 1 dan charge 3. So K is 9 to the power of 9. Q1 is 2 to the power of negative 6 microcoulomb. Q3 is 4 to the power of negative 6. Divide by, okay, proper distance separation antara dua charges ni, so kita boleh gunakan theorem Pythagoras. Here is 0.3, so here is 0.4, so here will be 0.5 meter. So the separation is 0.5 squared. So we will get F31 will be 0.288 Newton. Okay, then we find F32, we calculate F32, so F32 will be K Q3 Q2 over R squared. The R will be the separation between charge 3 and charge 2 lah. Then we put in the value, K is 9 to the power of positive 9. The charge Q3 is 4 to the power of negative 6. Charge Q2 is 2 to the power of negative 6. Divide by, the separation between the two charges also the same, 0.5 squared. So when we do calculation, we will get the F32 will be 0.288 Newton. Okay, so after we already get F31 and F32, the magnitude of the forces, we are going to add back. We are going to do the summation of vector by considering the direction. So because both forces act at certain angles, so we need to resolve the forces in order to do the summation. So we have the force, so we have to resolve it into component X and also component Y. So we have F1, F13. Okay, so kalau kita perhatikan F13, so F13 can be resolved into the horizontal component. It will be F31 cos theta, and then it can also resolve into the Y component, F31 sin theta, and it will be negative because it's pointing downward. The component is pointing downward. Since go for F32, we can resolve it into horizontal component, F32 cos theta, and also the Y component, F32 sin theta. Okay, so we write here. So F32. So for F32, we are going to have F32 cos theta. So it will be 0.288 cos 36.9 degree. Then the component Y will be 0.288 sin 36.9 degree. Then we have F31. So F31 we have 0.288 cos 36.9 degree. Then for the component Y, so if you notice component Y for 3, 1 will be pointing downwards, so we have to consider the direction. So it will be negative 0.288 sine 36.9 degree. Then we do the summation for component x and y separately. So we will get the summation of forces. The net force along the x-axis will be 0.46 Newton. Okay, for component y, when we do the summation, we get the value is 0 Newton. So after that, we apply the theorem Pythagoras, so we can find the magnitude of force acting on the charge Q3. So the net force acting on charge Q3 will be the square root of total force along component x squared plus total force along component y squared. So we are going to have 0.46 squared plus 0 squared. So we still get 0.46 Newton. So you will notice that the net electric force acting on charge Q3 is only along horizontal component, so the direction will be, since it's positive, so it will be to the right. Okay, so this one will be our answer. So boys and girls, you can try your tutorial 1. Question 4, that we apply the same concept before you continue with the next video.